Good morning, everyone. Today we're going to continue our discussion on descriptive financial analytics and visualization. Last time, what we did was to learn how to use LaTeX in order to show formulas in formulas in finance, just like this one. The return of an asset R sub T. So this is for a single period simple return. Okay, single period only. So which means that it's the formula for, if you're looking at the price of the asset yesterday, let's say the price of the asset yesterday was 100, and the price today became 102. So if you want to compute for the simple return, single period, because this is only single period, then it's P sub T, price at time T, divided by price at time T minus 1, yung previous price, minus 1. So that's price at time T, this is 102, divided by 100 minus 1. So that's 1.02 minus 1, so that's 2%, okay? 2%. So we say that the simple return of this asset from comparing today and yesterday was 2%. So single period, okay? And then simple return. Now, if it's multi-period class, if it's multi-period, this is the formula. Here. Okay, this is the formula. So we derived the formula class. So 1 plus R total. Notice that it's R total. It's equal to 1 plus R1 plus 1 plus R2. Then we use the dots here, dot. Okay. And then 1 plus R sub T. So what does that mean? R sub 1 class is just like this one here. It's just like a single period simple return. So if we have, say, okay, suppose these are the prices of your asset. This is the price today. This is the price 1, 2, 3, 4, 5, 6, 7. 7 days ago, this was the price. And you'd like to know what is the return for this. Okay, how many periods is this class? Can you tell me how many periods? Kindly chat, please, everyone. How many periods do we have here? 8 periods, okay, 8. Okay, so let's see, class. Let's see. This is 1, 2, 3, 4, 5, 6, 7 periods only. Okay, there are 8 prices, but 7 periods. One price cannot be a period. Because if you say period, then what will be the returns of 10? You cannot determine the returns, class, if you have only one figure. It has to be compared with another figure. Okay, so 10 and 10 and then 11. So this is one period. Kaya class, the formula P sub T over P sub T minus 1, right? You can only compute for the returns, class, if you have the value today and the value yesterday. So this is one period. So you have to have 2 prices. Otherwise, you cannot compute the returns of only one price. So there are 7 periods here, class. So take note of that, okay? There are 8 prices, but there are 7 periods. One period has to cover 2 prices. Is that clear, class? Kindly chat, please. Is that clear? The number of periods and the number of prices. The number of asset prices is not the same as the number of periods. Unless in exceptional cases, the number of periods will be equal to the number of prices minus 1. Okay, all right, good, thank you. Okay, so the question now is, oops, sorry. What is the return for this asset prices for this whole period, the total period? So there are, as we said, there are 7 periods. So if there are 7 periods, how do we compute for the simple return? Okay, simple return. Now we're told here in class that for multi-period simple return, for multi-period simple returns, okay, it is multiplicative. Okay, it is multiplicative. Hence this formula. Hence this formula, class. Okay, so if you haven't checked the text that I shared with you, please do so because it's there. This one. Okay, class. If you take a look at this, so 1 plus R total. R total is the returns for the, sorry, I deleted the prices for the 7-day period. I think it started with 10 and ended with 8, right? So R total is the returns for this total period. Okay, not only one period, not a single period. And how do we get the period returns? It's multiplicative. 1 plus R1 plus 1 plus R2 up to 1 plus RT. R sub T is the last period. Okay, and it's equal to this one can be expressed as product pi. Okay, you know the sigma, right? Sigma means addition. Product is this one, pi. Okay, so if we have a quick review of the LaTeX, okay, so we have here, take a look at this class. We're using product, okay, and then T is equal to 1 is here. Oops, sorry, Z. This is the one below here, underscore T is equal to 1, and the one above here, caret. So this should be, it's better to put this T is equal to capital T. Okay. And then 1 plus R sub T. And minus 1. Okay. So for example, if you gain 10% in period 1 and 5% in period 2, what will be the total return? As the name suggests, okay. As the name suggests, class, in period 1, the return was how many? 10%, okay? Period 1, 10%. Period 2, the return was 5%. Okay, maybe we can add another period. Period 3 was 6%. Period 4 was, let's say, it lost 2%, okay? 2%. So the question is, what is the total return? R total. R total. So this one class has 4 returns, which means that there are 5 asset prices here, right? So this one means that there are 2 asset prices here, right? So 4 returns, 5 asset prices. So how do we now get the total returns? Simple returns class, simple, we're talking of simple returns. So our total will be equal to, okay, multiplicative class, 1 plus return 1 plus 10%, then 1 plus 5%, that's 1.05, right? And then 1 plus 6% times 1.06, and then 1 plus negative 2%, so that's 0.98. Okay, get the product of each of all of this, and then minus 1. Okay, 10, 5, 6, negative 2. Okay, can you try in R class? What's the answer? What's the answer for that class? What's the total return for this multi-period? Anyone? Of course, class, this is 0.98 because 1 plus negative 2%, right? So everything for the gains, for those with positive returns, it will be greater than 1. For the ones with the loss, it will be less than 1. Here, 0.98. What's the answer, please? Anyone, please? Period 1 is 10%, period 2 is 5%, period 3 is 6%, period 4 is negative 2%. So what's the total returns, class, for this multi-period? .98%, Kent. Okay, thank you. How about the others? Let's see. 98% returns. .199, Kent. Okay. Change your answer. Okay, how about the others, class? Thank you, Kent. I hope the others are trying also. No, hindi lang nanonood. 0.2, Pablo, thank you, 0.2%. 0.2 ba to o ano? 0.2, so 20%. Okay, I'm only getting 2 answers. How about the rest of the 19 students? How about the other 17 students? Jason, thank you. 20%. Others, please. Abdul also has 20%. Okay, let's evaluate, class. Thank you so much for those who answered. Okay, let's evaluate. Okay, so I'll just write the formula here. So 1 plus 10%, right? 10%. I can write it this way, or I can write 0.1, or I can just directly write 1.1, and then 5%, 1 plus 0.5, and then 6%, right? 1 plus point, oops, sorry. I have to put here multiply 0.06 multiply 1 minus 0.02, okay, and then minus 1. Okay, class, right? Kasi multiplicative ang simple returns, class. Multi-period, multiplicative siya. It's the product of the returns minus 1. 1 plus 0.1 times 1.05 plus 1.06 times 1 minus 0.02, no? Minus 1. You have to subtract 1 at the end Control Enter. So it's 0.1998. Okay. So all of you are correct. Those who answered, thank you so much. That's good. So that's 19.98%. Okay. Any questions, class? I want to be clarified if you got it, if everybody got it. I hope that, everybody will answer. Any questions with this problem, class? Okay, good. How about the others? Clear? Okay, none. Okay, good. Okay, good. Thank you. Thank you, everyone. Okay. Now we go to log returns, class. Or another name for it is continuous compounded returns. Okay. So log returns are more advantageous to be used for as far as financial analysis is concerned. Okay, and they're derived from the natural logarithm of price ratios. They're widely used in quantitative finance and academic research. Okay, so have I shared this with you, class? Itong notes na to? Did I? If not, class, sige, i-ano ko na lang. So that can put it in your notes. Okay. So which is more preferred, class? Simple returns or log returns? Log returns. Okay. In finance, we prefer log returns. That's why in most researches, you'll see that that when you're dealing with growth rate, you use log and not just the simple growth rate. Okay. So I'll just explain the formula. Okay. I think I gave this also in the okay, let me anyway just give this. Okay, so take a look at the formula, class. Okay, in the previous discussion, class, we had a comprehensive discussion of this. Unfortunately, in this class, we were cut off because of some technical glitches. But in the other class, we were able to discuss it, and I posted the video. So please watch the video, class, so that you can see how this is being done. Okay, notice first of all that there's a difference between the designation of the returns. For simple returns, it's capitalized, right? And you'll see this in most textbooks, most literature, R sub t. For log returns, we use small letter R sub t. Okay? Whereas R sub t is equal to the price at time t over price at time t minus 1. Okay? By the way, class, let me just reiterate that this one is equivalent to P sub t minus P sub t minus 1, close parenthesis, minus P sub t minus 1. Okay. However, it's really recommended not to use this, class, because this is too unwieldy when you're doing computation. Mas mabilis to, class, straightforward. Just get the ratio of the price today divided by and the yesterday minus 1. So I don't expect you to be using this, class. Ito. Ay, nawala tuloy yung ano. So anyway, class, R sub t, simple return, as compared to log return, R sub t. And it's obtained by getting the log. In log class, okay, the logs can have many bases. Okay, for example, what's the log of 100? What's the log of 100, class? The answer is 2. Why 2? Because the assumption is that when it's not given, the base here is 10. Okay? And log of 100 is equal to 2 because the base of 10 raised to the power 2 is equal to 100. Or in other words, okay, what number when we raised 10 with will give us 100? So that's the definition of log. However, in finance, we normally use the natural logarithm. Okay, the natural logarithm. In books, when you use not natural logarithm, you use ln, class, natural logarithm. This is logarithm to the base n. Natural logarithm is logarithm to the base e. So this is log of what number raised to the base e. Okay, base e. This is base 10. This is base e. Okay, what's e, class? What's the value of e? Can anyone tell me, class? What is the value of e? In the chat box, class, please. Can somebody tell me what is the value of e? Okay, thank you. Yeah, you're correct. Jason, Ricardo, Kim, yeah, you're correct. And e is a transcendental number, or it's an irrational number, which means it's non-repeating, non-terminating. Okay. If you write e, run it in a very powerful supercomputer, it will generate thousands, millions of pages, and it hasn't even finished yet because it's a non-repeating, non-terminating. The pages can go up to the moon and back and up to the moon and back, and you will not find a pattern. Okay, it's a non-repeating, non-terminating. It's a transcendental number or irrational number. Okay, so you can get, class, the value of e is this one. Let me see if it will. No, this is, sorry, no, not allowed. EXP lang. Sorry, EXP1. Okay, there, class. E to the 1. So in R, we use EXP, exponential, okay? E to the 1. So in R, we also use log, LOG. We don't use LN, okay? But when you use log in R, okay, it means, class, for example, log of E, class. What is the log of E, class? Answer, please. What's the log of E? Log of E is? Yeah. Okay, correct. Correct. Why is that so, class? Why is it equal to 1? Because, as we said, by definition, class, by definition, log of E is equal to what? And by definition, in R, when you use log, it's automatic that the base is E. There. It's not 10. Okay? If you want to use 10, then you'll have to specify. So what number is it that when E is raised to that number will give you E? Of course, the answer is 1. There. So E to the 1 is equal to E. Okay, that's why R is giving us log of E. Log of E is equal to 1. Okay, anyway. Okay. However, class, if you say, okay, log of 100. A while ago, we said log of 100 is equal to what, class? Is equal to 2, because 10 to the 2 is equal to 100. However, that's assuming that that the base is 10. And when you're reading books, class, when you see the log, it is understood that the base is 10. Okay? When you see ln, it is understood that the base is e. However, in R, the default is that the log, class, if you use log, it's always base e. The base is your exponential. So for example, this one, log of 100, this will not give us 2 class. Okay, you notice that it's equal to 4.06, 4.60, Why is this so? Why is this so? Because log in R does not use 10 as the base. Okay, in fact, if we check E class, so E raised to this one class. Oops, sorry. $4.60517. Okay. So what's the value of this one class? E to the 4.60517. Answer is, yeah, 100. Okay. It's not exactly 100 because I just copied it's not actually 4.60517. It's more. Okay. All right. Okay. Thank you. Okay. So let's now go to a property of log. By the way, one last thing. One last thing, class. If you want to use log the base 10, then you do this log of 100, then identify the base should be 10. Okay, that's how you write log using the base 10. Can you check this, class? What's the log of 100? And then identify the base that I'm going to use is 10. What's the answer, class? Yeah, that's correct. It's now 2, class. It's now 2, which is the regular way of writing in the books, class. Okay, so log of 100, you have to define, class, base 10. Okay, now log, class, is a very important property. The log of a quotient, okay, is equal to the difference of the logs. So the formula, class, to get the log return is log or ln. Okay, in R it's log of p sub t over p sub t minus 1, which is maybe I should just replace this by log. Okay. Okay. Anyway, the context here is that it's log, right? Log. So this is context in R, which means the base is there you go. Okay, log of p sub t over p sub t minus 1, okay, is equal to log of p sub t minus log of p sub t minus 1. And p sub t is the price of the asset at time t, and p sub t minus 1 is the price of the asset at time t minus 1. Okay? Okay, so here I'll put log here. Log denotes the natural logarithm. Okay? All right, clear to, class? Clear? Is this clear? Kindly chat, please. Formula for the log. Okay, good. Thank you. All right. So as we said, in this class, we're going to use using log, no? We're going to use the log formula and not the simple returns. Okay. Example class, interpretation. R sub t. Now for small returns, let's say less than 5%, okay, take note of this. For very small returns, class, R sub t, log returns, is approximately, okay, let me put this here, class, so that you can see the printout. There, class. R sub t is, let me add this, class, sorry. Let me put it in the latex. I have to put it in text. Next line. There you go. Okay, class. So this is a statement. For small returns, class, for example, less than 5%, your log returns will be approximately equal to your simple returns. Okay, so I hope that concept is clear, class. If the returns are very small, then approximately pareho lang yung yung log returns at saka yung simple returns. Example, class, example. Let's put an example. Price at 100, then let's say it went to, just for purpose of the example, class, 100 point, if this is possible, 100 pesos naging point, naging halos ano lang, point, and halos 100 point, sige, 01 na lang. Gawin natin stock price at 1,000, and then it became 1,001. So you have this asset. Yesterday, the price was 1,000. Now the price is 1,000.01. So 1 centavo lang yung in-increase niya. Okay, so let's compute for the, let me put here, let's compute for the, okay, I place a hashtag, which means it's a comment, so that it will not return an error. So for the simple return class, it's the price now, right? Control C divided by the price yesterday. Control C, Control V, minus 1. Okay. And then for log returns, it's ln or log price at time t, Control C, Control V, divided by this one. Okay. And then another one, just to show that the formula, this one, is equal to log minus log. So it's equal to log of, I'll just write it, 1,000.01 minus log 1,000. Close. Okay, let me. Okay, take a look at what I wrote, class. I'm writing three numbers here. Simple return. Price at time t divided by price at time t minus 1, right? The other one is log of p sub t over p sub t minus 1. Notice we don't subtract 1 here. Here we subtract 1. And the other one is log of price at time t minus log of price at time t minus 1. So if you run this class, Control Enter, what do you notice? Okay. So we can actually change the format of this. Okay. But it's a very, very small number, no? And then siguro, sorry let's change our example kasi masyadong maliit naman. Masyadong exage naman yung answer ko, class. I'll make it, okay, I'll make it less than 5% naman, di ba? So I'll make it 1,000, kahit 1,000, 1,003, for example. Oops. Or 1,000, 1010. Kasi 1010, 1000, that's just 1%. I think the example I gave is so exaggerated. So I'm changing it, class. I'm sorry about the example. So 1010 from 1000. So that's actually only only 1% lang, 1, 2, 3. Only 1% increase. And that's less than 0.05. So if we run this class, okay, what do you notice? 0.01, 0.00995, 0.0995. Pareho lang to, of course, yung pangalawa. And then we're saying that R sub t, this is big R sub t, the simple return, is approximately equal to the small r sub t. Okay, you can see here that if we round this off to the next decimal place, it's practically the same, 0.01 then 0.01. Okay? All right, I'll increase it a bit. Ang 1,100 kasi 10% na yun, no? Ang 1,050. Okay? I make it 1,050, make it 1,050. Okay. So here, class. Okay, this is 5%. No? And, okay, approximately, class, no? Pag 5% or less daw, approximately the same. So, I made it quite higher, 5%, and you can see that it's not a bit equal to, but it's approximately equal to. Had I changed this to, sorry for showing this, class, 40, 40. Okay, and then this will be a, control enter, yun, 0.392, approximately 4%. And you notice, class, that the log returns is lower. Okay, notice in all instances here, the log returns is lower compared to your simple returns. All right, I think I made myself clear. Any, is this clear, class? Comments, please. Okay, good. All right. Now, now this time, class, for multi-period. Okay, because we already studied simple return, single period. Okay, simple return, multiple period, and then log return, single period. This time, this is your, okay, your multiple log return, multiple period. Notice that the formula is additive. And this is one advantage of using your log returns. Okay, unlike for simple returns, it's multiplicative. For log returns, it's additive. So take a look at this. Here, a key advantage, class, of log returns is that they are additive over multiple periods. So you have R1 plus R2 plus R3. These are your log returns over T periods, class. To get the total return, you just add them. Okay, you just add them. We can create an Excel, class, Excel sheet. Okay, maybe I'll just send it, class. I'll send it over class, just to show you how we can prove that indeed the total returns, class, of the of a log, the total log returns is equal to the sum of the individual returns. All right. Okay, so for here, as an example, did I give this to you? Do you have this, class? Do you have the formula, class? No? Okay, sige. I'll send it now. Here. This one I gave, right? I'll take it from here. There. So as an example, class, you have return in period 1 is 0.0953, return in period 2 is 0.0488, The total return is just adding. You add everything. Okay, this one class. So let me copy this. Control C. There. All right. Oops. What happened here? Enter. So the total return class for the two periods is 0.1441. Okay. Now, if you want to convert this one, the log returns, into the simple returns, this is what you do, class. The formula, class, is, okay, let me write the formula. Hindi ko yata LaTeX yun. I leave you, class, to do the LaTeX for that. Okay. So to convert, class, R sub T. So if you want to get the simple returns, R sub T, it's equal to E to the R sub T minus 1. Okay? This one. Okay, maybe we can put it in LaTeX as a practice. Okay, let's put it in LaTeX, class. And you write with me, class. I will not. Okay, let's do the LaTeX for this one. $, $, $. Then let's put here text slash text, open, convert formula to convert log returns to simple returns. Okay. Then let's put this in to the next line. Okay. Next line to convert. Okay. So we have R sub T, R. Okay. R sub T is equal to, okay, E to the E to the R T, okay, minus 1. There you go. Formula to convert log returns to simple returns. R sub T is equal to E to the R sub T. Okay, so this is the log returns. Therefore, the simple returns will be E. In R, it will be EXP. E to the RT. What's RT? Let me just copy this. Or you can just put 0.1441. Control C. Anyway, I'll just put the sum here. Okay. The sum of these two. And then minus 1. So what's the simple returns, class? What's the equivalent of the simple returns? Answer, please. Great. Okay, very good, class, very good. And as expected, it will be greater, class. It will be higher than the log returns. Okay, let me pause for a while, class. So far, how is our pace, class? Is my pace okay? Am I going too fast? Am I going too slow? Comment, class, will be appreciated. Okay, lang, good. Thank you so much. Okay. I hope you don't mind me speeding up a bit, no, for uh, as we go along. All right. So let's start with this one, class, already. I'd like to, this one are just examples. Okay, as I said, class, the advantage of log returns, it's because of its additivity. Okay, let me share this with you. Additivity, class. No? You can, the computation for multi-period is simplified because you can just add the returns. Okay, and especially this is very useful for time series analysis. Okay, here I have an example. Okay, if you take a look at this, class, the ratio of P sub t over P sub t minus 1 is 1.1, which means that the return is equal to 10%. Because if we subtract 1 here, of course, if you subtract 1 here, then that will mean this is already the simple return. So you also subtract 1 here. Okay, so a simple return of 10%, okay, and a simple loss of here on the other hand, a 10% loss. Okay, a 10% loss means that the P sub t over P sub t minus 1 is equal to 0.9. All right, so here it just tells us that ln, okay, ln of 1.1, okay, the log of 1.1, okay, if you get the log of 1.1, it's 0.0953. And the log of 0.09, which is a 10% loss, log of 0.9, I'm sorry, which is a 10% loss, is here, no, negative 0.10. It's a loss of 10%. Okay, notice that log returns are more symmetric. They're more symmetric. Log returns often exhibits more desirable properties. That's why I said that in, I'll share this. That's why I said that log returns are much favored over simple returns. So in all our cases, class, we always use log returns. Time na. We weren't even able to start with this one. Just 1 minute, class, kindly load this. Okay, I'm sure you haven't loaded quant mode and performance analytics. You may go now if you need to do so. I'll just spend just a minute or two just discussing these get symbols, and then the point is for me to include it in the recording. Okay, but you may go, class. So if last time we learned that if you don't have that package, okay, you have to check packages and then type here quant mode. So if you don't have quant mode here, what you do is install. You can go here, install, and then type quant mode. Quant mode. Okay, include and install dependencies and then install. Okay, and do the same for performance analytics. So when this is loaded already and you check again here, you'll notice that it's found here already, but it's not yet checked. What does that mean? Installing a package does not necessarily mean that you automatically have access to it. You have to use library. Clicking here, class, for example, if I click this one, a bind, see what happens. Clicking this package in the library is equivalent to running library there. Same with performance analytics. Okay. So once you have installed this quant mode and performance analytics, okay, and then require it or uh, let's say use library in order to make it available. There. So we're going to make use of this class. We're going to make use of the get symbols function in acquiring data from several databases like Yahoo Finance. So this is how you write the function, get symbols, and then write the ticker symbol. This is Apple ticker symbol. Source is equal to Yahoo. Here. Source is equal to Yahoo. And then the dates from 2020-01-01 to 2024, June 30. And then auto.assign is equal to true, which means that you're telling R to create an object called Apple and name it as Apple. Okay. For this one, you're creating an object, Apple close, and it's the Apple object, in particular, the adjusted price. If I run this one, let me show you first. If I run this one, you'll notice now in our environment, I have this Apple object, and it's an XTS object. Okay, and I also have, if I print this one here, you have this OHLC, okay? OHLCV data, open, high, low, close, volume adjusted. And you can see here that it's from January 2, 2020 until June, okay, June of 2024. Okay, and then what I did was to create another object, Apple adjusted close, and it's here, class. Open, Apple adjusted close, and it's only the adjusted price. So we were able to subset what we needed. So this is another object. Okay, so let me stop here. Okay, we'll continue this next